Welcome to the Career Cafe, a place where teenagers ask experts. Today, we will be discussing the insights of astrophysics over some chocolate cake. We will cover the opportunities and scope of astrophysics as a career, the process of getting entry into an astrophysics college, and the applications of astrophysics in this episode. I am your host, Piyush Kolhe, for the astrophysics episode, and I look forward to getting answers to all of your great questions. Today, I have invited Dr. Shantanu Desai as our astrophysics expert. Dr. Desai is an associate professor in the physics department at IIT Hyderabad and was awarded the 2016 Breakthrough Prize in Fundamental Physics as a part of the Super Kamiokande collaboration. And we look forward to discussing your questions with them. I am glad that you were able to join us today, sir. How are you doing?
Good, thank you very much.
So, we had a survey in our community and we collected some very intriguing questions, out of which I think one should be addressed first. How does one know if astrophysics is a suitable career for them?
Yeah, see, the thing is, if you are really fascinated by, if you want to do research, that's number one, I guess, requirement. And if you are fascinated by space, the wider cosmos, sky, what happens? If you have ever wondered, if you have looked at the night sky, gazed at the night sky, and wondered where are the stars come from? Where do we come from? What is our future? What is our place in the universe? If these questions fascinate you, right, then yes, in astrophysics, and if you are prepared to do research, then obviously astrophysics is a career for you. But also, I should mention that this is also a risky proposition because to have a research career in astrophysics, you need to also be good in physics, math, computing, computers. Nowadays, everything is done with computers, and also in general other branch of science. Okay, and in general, these qualities are needed for research in all branches of science and engineering, but especially for astrophysics.
Yes, sir. So, there's another question. What are the career options or job placements available after getting an astrophysics degree? This is a popular one. We've got this question from many people.
So, just to be clear, by degree you mean a PhD degree, I presume, right? Or
Yes, sir.
Or an undergraduate or a PhD degree.
Whatever
right?
level is there, like masters or PhD, what are the opportunities that open up?
Okay, let me start with the PhD. Yeah. So usually, right, okay, so after PhD there are two options, right? If you want to continue to remain in academia, you can apply to universities or any teaching institutes or research institutes which focus exclusively on astrophysics. That's one option, okay? Now, second option is while working on astrophysics, let's say if you decide that a long-term research goal is not research career is not your cup of tea, then a lot of people after PhD in astrophysics, they go to data science, they go to finance companies, stock markets. They also, those who work on experimental stuff can also go into medical physics and so on and so forth. So the kind of data analysis skills, computing skills which they've acquired during the PhD, right? They directly apply. I can give examples later on if someone is really interested. So these are the broad two career option. Obviously, there's a third option also. People can also go for outreach, jobs like in planetariums, science education centers, and all that. So.
Okay, thank you for that. And what about after doing a master's degree?
After a master's degree, again, also, I guess almost all people apply for a PhD, and if not, again, you can actually you can apply again for obviously you cannot get a job in a undergraduate institute or universities, but you can apply for teaching jobs at colleges, 10+2 colleges. Some again look for science education, working in a planetarium or some similar things. Some also work as the research interns in the research lab. But it's hard to get like permanent jobs there. So many people just work for a time and then either apply for PhD or then apply in industries.
Yes, sir. And like you hinted at earlier that you need to know a lot of physics, a lot of maths, a lot of like other sciences, and you also need to know computing. So could we just discuss that a bit more in detail, as in what are the actual skills in those things? Like what level should you be at to be an astrophysicist?
So it depends on what kind of astrophysics you want to do, right? But in any if you want to do astrophysics research, obviously you need to be good in physics. Usually, I think almost all areas of physics except probably solid state physics is needed in astrophysics. Even solid state physics is important if you want to like build telescopes and other things. And math, obviously, it's ultimately we all deal in numbers and computer computations, and obviously nowadays everything is done in the computer, right? If you so obviously you should be able to be quick at learning new programming languages, applying what you have learned to solve problems in astrophysics. Okay, because almost all nowadays. I think astronomy has become like a big data science. Okay, there are like million terabytes of petabytes of data you have to deal with. You should be proficient in like downloading the data, manipulating the data, and so on and so forth. Okay, so I guess that's what I meant.
Okay, sir. And what is the main difference between a BSc in physics and a BTech in physics, and how does what is better for someone who is interested in theoretical physics or astrophysics?
Okay, so right now, as far as I know, in India there's no BTech in physics per se. There's BTech in engineering physics. Okay, which is offered in IITs and some IITs, some NITs. As far as I know, it's not offered in any Indian university. So BTech in engineering physics, I mean, if you know of any exceptions of any universities which offer BTech in physics, let me know. But as far as I know, there are no universities which offer just a BTech in physics first. Okay, so BTech in engineering physics usually, right, is a mixture of physics courses, engineering courses, computer science courses in IIT Hyderabad. There are also you can take courses, mechanical engineering courses, and so on. So typically a 4-year program. BSc is typically a 3-year program, okay, which is just basic physics. You won't get exposed to sort of applied areas of physics, and you may not be as exposed to like computer programming, electrical engineering as compared to the engineering branches. Okay, now which of this is better? That really depends on the case, right? I mean, usually, right, if you want to do more applied astrophysics, like which involve I think instrumentation, observations, and all that, then I think BTech might be a better choice. But again, BSc is also not bad. And usually, though, many people also apply to astrophysics for a PhD after an MSc. Okay, like very few people directly apply after BSc. Okay, and even now, those who do BTech now in many IITs, the BTech curriculum, the final year is equivalent to an MSc curriculum. So in some sense, BTech is more advanced than a BSc. Okay, but again, BTech you might not be exposed to as much detail into physics as say BSc, because BSc is exclusively physics. Okay, so I guess there's no one answer. I think both are better. Both are good depending on what one wants to do. And in both of these cases, right, usually both BTech or BSc, one usually does a project. Okay, a project is where someone just digs into astrophysics and all that. Okay, so that's where you get an idea of whether astrophysics is really a cup of tea or not. Okay, when you do the project.
Yeah, that was very informative and helpful. Also, there's another question we have, that other than a BTech in engineering physics, are there any other engineering degrees from which we can go to astrophysics?
Yeah. So many people also go to astrophysics after a BTech in electrical engineering, mechanical engineering, they are very well known examples in India itself, whom probably you can interview in one of your next series episodes of the same series. Yes, but even in those cases, right, typically they do some project in astrophysics either during their summer breaks or during their final year when they have to do a 1 year BTech project and some.
Okay.
So yes, the answer is yes, and obviously their background in physics may not be as strong as the people who have done a BTech in physics or engineering physics or BSc or MSc in physics. But they can make up for it in this thing. They'll have some other skills in building astronomical instrumentation, like electrical engineering or mechanical engineering skills they have, which will be very useful for building electrical engineering and for building like astronomical telescopes and all that. But I know students with the BTech in electrical engineering who have done more theoretical, who have like gone to theoretical areas of astrophysics also. So there's again no hard and fast rule. It just depends on like what motivates you and how much effort you put in. Sometimes you might have to put an extra effort beyond what is taught in your curriculum. Okay, so.
And also from what I've read online, what I've heard basically, field experience for astrophysics, that is like academic and research opportunities, varies significantly from place to place, and many say that the US is one of the best locations for careers related to the pure sciences. Is it true that there are particular places where academics and researchers find more opportunities and can have more flourishing careers as compared to other places? And if so, which place would you recommend for a career and for the education?
Okay, so this is again a difficult question to answer. So obviously, I guess the exciting things, all the state of the art discoveries are obviously happening in USA. However, the thing is nowadays science is not done in isolation, okay, and it's not possible for one person or one university to do everything. Okay, so many of these projects which US universities are involved in or leading, they also involve a collaboration with international universities, Indian universities. Okay, I mean, Indian universities involved in all the major astronomy projects like LIGO, 30-meter telescope, many others. Okay, so you can, even if you apply for a PhD at Indian University, Indian Institute, or for some or for that matter a non-US or a non-Indian universities, even then you will get an opportunity to work with state of the art. You can get an opportunity to do as top-notch research as a PhD student in USA for that matter. Now, obviously, if you want to work on theoretical subjects, there are obviously very good people in India also. For theory, you just need a pen and a paper, maybe a computer, which you can get. Okay, so yes, you can get very good research opportunities in India also as compared to USA. Now, let's say about 20 years or so ago, right before internet and all that. Obviously, in US, I think you would have got a lot more, I think, exposure to other different areas of astronomy and astrophysics, more chance to meet other people. But now, because of internet and Zoom meetings, and nowadays, since the last 1 year, all seminars are also online. Okay, so now that advantage is has gone. So the answer is yes. In India itself, also you can do as good research as in USA. Now there are some other aspects also, like some people who go to US somehow they couldn't go. They had like culture shock, this that. Okay, whereas if they would have done the same thing in India, they wouldn't have culture shock. So there are some other advantages of working in India also as compared to non-science reasons other than science and whatever technology. But obviously in US, if you think you can do well, then yes, obviously US also there are lots of opportunities. Hopefully that answers the question.
Yeah, that was a really great answer and a comprehensive one at that. And so, what exactly does an astrophysicist face in the field? What are the main challenges an astrophysicist faces?
Well, it depends on what exactly you're working on. Let's say an observational astronomer, right? That person has to apply, he has to apply for observing time at telescopes. Okay, so in the GMRT radio telescope India is like oversubscribed. Okay, so you need to apply for observing time. Okay, and that's one thing. Second thing, obviously, you need to be able to write papers, communicate the findings of your results to your peers, to your colleagues, to your students, and I guess get funding also for your, if you're a professional astrophysicist. Okay. Now, if you're just a theoretical astrophysicist who doesn't go to telescopes, then obviously your main challenge is to interpret observations which your colleagues have taken. Okay, try to see if they can be fit well with, they can be explained with existing theories, or you need new theories. Okay, then there's a third kind of astronomers who build instruments. So their main challenge is to build state-of-the-art instruments. Make sure the instruments won't fail. They won't. If you're flying a spacecraft, they won't explode when this thing goes. And even if it does, it takes state-of-the-art data. Okay, state-of-the-art exquisite data, much better than previous generation instruments. Okay, so there are these three different kinds of astrophysics. Each of them face different kinds of challenges.
Yes, sir. Thank you for that. And so we also have a very interesting question from a few of our audience members. Is that so? From what they've heard and what I've heard, you need to be at a really prestigious university or a prestigious college to get a degree, and so that you get better research opportunity, so that you get a bit of better exposure to the field. Is that true? Like, how does
Okay, so let me back up. So by degree, do you mean undergraduate degree or a PhD degree?
Undergraduate, because that's where it all starts, right?
Yeah. So there's nothing like that. Usually, right, all the research institutes in India offer have summer programs, summer research programs to students from all universities. Okay, and using that, and all IITs also have a summer internship programs. All of them, they usually take students from outside their universities. Okay, from outside their institutes. Okay, now obviously to be accepted in these institutes, the assumption is that the student has first of all done well in his school. Let's take the case of a student who is not from a top university. Okay, the assumption is that if the student should have done well in his classes and courses there, and then he can apply for research in these other institutes. Okay, now obviously that student will be competing with students from other good universities. Okay, but that's fine. Some people hold an interview, and the student does well in interview, he'll get lots of opportunities. Now, in astronomy, right, also in many cities there's like amateur astronomical association. Okay, so although the main job is not research but just to do EPO outreach, you learn a lot if you become member of these societies. Okay, now this is true obviously only for astronomy. Someone wants to do pure theoretical physics and all that, this is not possible. And then beyond that, yes, nowadays you can just do research. Nowadays, in the era of internet and all that, you can just do research on your own by contacting various people. That if you're motivated, yes, nothing can stop you. Obviously, people who are from a good universities, they do have a little bit of an advantage. But even then, they have to study, right? There's no point having the best teachers if they don't put in effort. Okay, if they don't do well in the classes, or if they don't utilize the opportunities they have got to do research. Okay, so basically the answer to the first question is no, they are not at a disadvantage. If they do well in their classes, if they are motivated, they can do as well as the students from the best universities. And even the students from the best universities, nothing will come to them on a platter. Okay? They still have to put in effort. Okay? Hopefully I answered that.
Yes, sir, you did. Thank you. And just one last question is, what is the most important piece of advice that you would give to an aspiring astrophysicist?
So it depends on when, at what point. I mean, if the student is at an undergraduate degrees, even earlier than that, or let's say, or the student has completed BTech, at what stage?
So at like all the three levels. So before undergraduate for someone who's
Okay, so if before undergraduate, first of all, don't stress too much. Just pursue your passion. Just do well in your exams and other classes, and try to whatever free time you have, try to read up books on astronomy and this thing. See if it's your cup of tea. If your local city has some amateur astronomical association, just join them. If you live in a city which has like IITs or ICERs or something like that, some of them, just talk to some of the professors there. Okay. Now, if if let's say if you're in your bachelor's program, then focus on your courses, do well, try to do well. Again, try to this thing get try to gain some research experience during your summers. Obviously, the last 1 year, all summer programs were cancelled, so such situations are beyond our control. But in normal situation, try to get experience in research and so on and so forth, and this will help you. Now, if you have done your bachelor's, then you can decide yourself: do I need to take time off and either take a job? And how do I decide if a career in astronomy is really my cup of tea? If you feel you can do it, then apply immediately for graduate school, either India or abroad, wherever you want to go. But if you're not sure, take time off for a year or something, do a job, work in a research lab with some astrophysicist, and then decide if you want to pursue a research career in astrophysics or not. Okay. But in all the cases, or just one more, in all the three cases, don't stress yourself too much. Don't feel burdened, pressure. There are lots of other areas of research areas of interest. You might like to do research in fields other than astrophysics also. Like some people start out in astrophysics, but they realize that computing is that thing. Don't be shy. Just jump into computing. Just do whatever interests you the most.
Thank you. That was some really great advice. And thank you so much for your incredible insights. We appreciate you taking some time out from your such a busy schedule and joining us for this podcast episode. Thank you so much.
Thank you.
I believe that this discussion was insightful, and I hope that my listeners feel so as well. Please do leave your reviews and share this podcast. And to learn more, please follow us on our Instagram, Twitter, or Facebook page. We would love to know more about our listeners.